Good day to you mga ka-learners! This is Teacher Carmela. Welcome back to Solar Learning. Today, we will learn more about machines. Imagine what life would be like without the various means of transportation at present. How would you reach far places then? Look at what you are wearing. How is cloth made into the clothes you wear every day? Have you ever wondered how products like shampoos, detergents, and so many others that you use at home are produced? What do the producers of these products use to make them in great volumes? How are heavy objects like sacks of rice, cement, and others transported from one place to another quickly? To many people, the word work has several meanings. People consider earning a living as work. But in physics, the word has a specific meaning. It is used to describe what is accomplished by the action of a force when it acts on an object as the object moves through a distance. In this lesson, you will learn more about the meaning of work as used in physics. Here are a few pictures of some common jobs in a community. Look at them carefully and answer the following questions. Number 1, who among the people in the photos are doing work? Number 2, do your father and mother work? Do you work? Why do you say so? The answers to this activity may vary. Just consult your instructional manager or facilitator if you are not sure of your answers. Everyone in the pictures can be considered working in a general sense. But can their activities actually be considered work as defined in physics? The balut vendor, sorbitero, farmer, carpenter, and laundrywoman earn a living from what they do. But not all of them do work as defined in physics. In physics, work is done when a force acts upon an object, causing a displacement. A displacement is the shortest straight line from a starting point to the end point. In order for a force to do work on an object, the force must cause the object to move or the object must be displaced. Work, then, is defined as the product of the magnitude of the displacement and the component of the force parallel to the displacement. In equation 4, work is written as W is equal to Fd cosine theta, where F is the magnitude of the constant force, d is the magnitude of the displacement of the object, and theta is the angle between the direction of the force and the displacement. Let us study the situation in which the motion and the force are in the same direction. In this image, the force and the motion are in the same direction. Since the force and the motion are in the same direction, theta is equal to 0 and cosine theta is equal to 1. The equation for work is W is equal to F times D times cosine theta. But cosine theta is equal to 1, so this means W is equal to F times D times 1, or simply W is equal to F times D. To illustrate, the table in the picture was pushed a distance of 0.5 meter by a force of 30 newtons exerted by the man. The work done on the table is 30 newtons times 0.5 meter is equal to 15 newton meters. Work is measured in newton meters. A special name is given to this unit, the joule. 1 joule is equal to 1 newton meter. A force can be exerted on an object, yet it cannot be defined as work. An example is when you carry a bag of groceries in your hands which are at rest, like this in the picture. a force is exerted but the displacement is 0, so no work is done. You are not exerting force on the package equal to its weight in any direction. You also do not do work on the bag of groceries as you carry it even if you walk horizontally across the floor at a constant velocity. This means that no horizontal force is required to move the package at a constant velocity. You might exert an upward force to keep the package level. But since the force is perpendicular to the horizontal motion of the package, the force has nothing to do with the horizontal movement of the package. Therefore, that upward force to keep the package up is not doing work. If we apply the equation for work, W is equal to F times D times cosine theta, our answer is 0, since theta is equal to 90 degrees and cosine 90 degrees is equal to 0. Using that value in our equation, we get W is equal to F times D times 0, which is equal to 0. This means that when a particular force is perpendicular to the motion, no work is done by that force. Now that you have learned what work is, you can now study how to compute the amount of work done by a person. Solve for the amount of work done in the following problems. An object was pushed with a constant force of 500 newtons and moved a distance of 2 meters. How much work was done in moving the object? In this problem, we are given the following data. F is equal to 500 newtons, D is equal to 2 meters, and theta is equal to 0 degrees, because the force vector and the displacement vector were in the same direction. We are being asked to get the amount of work done on the object. Plugging in our given into our work equation, W is equal to F times D times cosine theta, we get W is equal to 500 newtons times 2 meters times cosine 0 degrees. W is equal to 1,000 Newton meters times 1. W is equal to 1,000 Newton meters or 1,000 joules. Therefore, the amount of work done in moving the object is 1,000 Newton meters or 1,000 joules. A 2 kilogram object is lifted to a height of 1.5 meters. How much work was done in lifting the object? In this problem, we are given the following. M is equal to 2 kilograms or the mass of the object, and D is equal to 1.5 meters. Right now, we are missing our force or F and W or work. To solve for F in problems such as this one, you should always remember that weight is equal to force. In our lesson on mass and weight, you know that weight is equal to mass times 9.8 meters per second squared, wherein 9.8 meters per second squared is a constant denoting the acceleration due to gravity, or the acceleration that acts on all objects that fall within the Earth's gravitational field. That is, for every second that an object falls, its speed increases by 9.8 meters per second squared. This means that to lift the object, you need to exert at least as much force as its weight. Our theta is equal to 0 degrees, making cosine theta equals 1, because the object is being moved in the same direction as the force being applied to it. So solving for work, we get W is equal to F times D. W is equal to M times 9.8 meters per second squared times 1.5 meters. W is equal to 2 kilograms times 9.8 meters per second squared times 1.5 meters. W is equal to 19.6 newtons times 1.5 meters. W is equal to 29.4 Newton meters or 29.4 joules. Therefore, the amount of work done on the object is 29.4 Newton meters or 29.4 joules. Let's look back at what we have learned in this lesson. Work is defined as the product of magnitude of the displacement and the component of the force parallel to its displacement. In equation, it is written as work is equal to F times D times cosine theta, where F is the magnitude of the constant force, D is the magnitude of the displacement of the object, and theta is the angle between the directions of the force and the displacement. Work is measured in Newton meters and is given a special name, the joule. 1 joule is equal to 1 Newton meter. The acceleration due to gravity is the acceleration that acts on all objects that fall within the Earth's gravitational field. It is equal to 9.8 meters per second squared. The force acting on a free-falling object is always equal to the mass of the object multiplied by acceleration due to gravity. In equation, it is written as weight is equal to mass times 9.8 meters per second squared. This is our lesson on work done and dusted, mga ka-learners. Stay tuned because in our next lesson, we will look at a few things that help us every day without even noticing it. Simple machines. See you then!